Okay, so we're going to start with a new chapter called equation of a line. Okay, chapter number 14. Okay, so here first we're going to understand what do you mean by linear equation. Okay, linear equation. You know what is linear equation? Linear, linear equation. You have linear equation in one variable and you have linear equation in two variable. So you can have standard form as ax plus by plus c is equal to 0. This is a standard form of linear equation in two variables where a, b and c, they belongs to what? Real number. Okay, and what is this x and y? This x and y, they are called variables. They are called variables, right? So if I have any line, say I have this line. Okay, so this particular line is made up of many points. Okay, is contain many points. So when I say many, how many points? Infinite points. So say this point is say x1 comma y1, and say this point is say x2 comma y2. So this particular equation will going to satisfy this equation of line. Means what? Means I can write a x1 plus b y1 plus c is equal to 0. Similarly, I can even write a x2 plus b y2 plus c is equal to 0. This is understood? Okay, so the next concept what we have is inclination of a line. So we have x-axis like this. Okay, this is my x-axis. Okay, and I can have many lines. I can have this as one line. I can have this as one line. Then I can have say this as another line. Okay, this is another line. So these lines are making an angle with positive direction of x-axis. Okay, like this. I will go to measure this angle. Okay, this particular angle from positive direction of x-axis. When I say positive direction of x-axis, what does that mean? That mean when I say positive direction of x-axis, it means that this is your x or positive, and this is your x dash. This is your x dash, that is negative. So I'm saying this angle is acute angle, right? So this theta is called inclination. This angle is called what? This angle, the meaning of this angle is inclination. Inclination of a line. So if someone asks you what is the inclination of this particular line, you will say theta is the inclination of this line. Similarly, if someone asks you what is the inclination of this line, you will say theta is the inclination of this line. Although it is a obtuse angle, always measure from positive direction of x-axis. But if you are measuring this from negative direction of x-axis, means like this, then I will going to refer this as minus say some angle, say phi, minus phi. I cannot say theta because theta I have used here, so it will be minus phi. So minus phi indicates what? That this particular angle I am measuring from negative direction of x-axis. Okay, that is the first difference. What is the second difference? Second difference is whenever you measure the angle from positive direction of x-axis, that is anti-clockwise direction. Whereas whenever you measure the angle from negative direction of x-axis, that is x dash, then that particular direction is clockwise direction. Okay, now I have okay, one more thing. I have drawn this x-axis. Okay, this is x-axis. Okay, this is x-axis. Now the what will be the, say I have one more line, say I have this line, this line. Can you tell me what is the angle between these two lines? The angles between these two lines is 0. Theta is 0 here, 0 degree, because there is no angle between these two lines. Okay, now if I draw this line, then say if I draw this line, then yes, then there is an angle of 90 degree. So theta in this case is 90 degree. So the inclination of between these two lines, say L1 and L2 is 0, and the inclination between L2 and L3 is 90 degree. This is clear to you? Fine. So now let's understand the concept of a slope. So if I have a x-axis like this is my x-axis, okay? And if I have a line like this, one line I have as this, okay, this is one line. Then another line, say this is one line, another line say I have like this, okay, and another line say I have like this. Fine. So what angle this particular line is making with this x-axis? What particular angle this particular line is making with this x-axis? It is making zero angle. It is making 0 degree. Okay. So if you keep a compass box or say ball or something on this, do you think this ball will going to roll here, or it will roll here, or it will be stationary? This will be stationary, correct? So when I say this will be stationary, it means I will say कि इसको slope नहीं है, there is no slope, so that the ball will go right hand side or left hand side. So in this line we can say that the slope is what? Slope of this line is 0. This line, slope of this line is 0. That's what I will going to say. Okay. Now, in this case, if I am keeping a ball here, say there is a ball. Okay. Say this is a ball like this. This is a ball. Do you think this ball will come down like this due to gravitational force? Yes, it will come down. So it has a slope. Yes, it has a slope. So this particular line has a slope. What will be the slope of this particular line? Less or more? This particular line will going to have less slope. Some number will be there. Okay, some number will be there, but it will be less. Now I am keeping the ball here. Now this ball will again come down due to gravitational force. So here what will be the slope? Slope will be less or more? It will be more. Why? Because gradient is more ना. Gradient means slope ज्यादा है ना यहाँ पे. तो इस बॉल की स्पीड यहाँ से नीचे जाने की ज्यादा है, ज्यादा स्पीड से जाएंगी और ये धीरे धीरे रोल करेंगी. क्यों? क्योंकि स्लोप कम है, यहाँ पर स्लोप ज्यादा है. तो हियर स्लोप इज मोर. This much is understood, right? Now let's understand the meaning of this slope. So the other name of slope is also gradient. Now that's what I will going to explain you now. Okay, समझो ये आपके पास ये ऐसा x axis है और ये y axis. This is x axis and this is y axis. Now what I will do, I will have one particular line like this. Say I am having a line like this. This is particular line, and I want to find the slope of this particular line. So when I'm saying I need to find the slope of this particular line, I mean I need to measure this. So to measure the slope, what I do, I measure this particular inclination, this particular theta, this particular angle I will going to measure. Okay. So now I'm finding the slope, means I'm giving the value of the slope. So the slope is what? The slope I can measure and I can denote by small m, and that is nothing but tan of angle. And how this angle will be measured? This angle theta will be measured from positive direction of x-axis. So if my theta is say 30 degree, so what will be the slope? The slope will be tan 30 degree, and tan 30 degree is it has some value, that is 1 upon root 3. Similarly, if theta is 45 degree, then slope has some value. Slope of this line will be what? Tan 45, which is 1. So if theta is 60 degree, then slope of this particular line will be tan of 60, which is nothing but root 3. Okay, this is one way to represent the slope. Okay, now there is a formula for tan. Okay, tan theta. There is a formula for tan theta. What does that mean? That means opposite side. Opposite side. Okay, whatever is there in front of theta, that side. Okay, divide by adjacent side. That's what is the formula for tan theta. So what I'll do, I will going to draw a means I will going to draw one line like this, and then I will going to draw one line like this. Just a minute. Here, this I have drawn. Okay, this is 90 degree. This will going to represent x, and this will going to represent y. And if this is theta, I will going to call this as theta. Why? What is the reason? Corresponding angle. So when I say slope of this line, which is represented as m, and I will going to call this as tan theta. So my okay, so I will going to represent this as tan theta. Then I can say y by x also. Why? Because opposite side, okay, to this angle is y. This is my y. And what is the adjacent side? Adjacent side is this x. This is that x. And what about this side? What is this side called? This side is called hypotenuse. Hypotenuse. This we are not using in slope. We are only finding the gradient, means change in y upon change in x. Now let's try to understand the slope by other way. Okay, same thing we will going to do, but this time we will going to derive the formula for slope. So here I have x-axis, x dash, and here I have y-axis, that is y and y dash, and I have a line this. Say I have a line this is a line. Okay, now this particular point A is say x2 comma y2, and this particular point B is say x1 comma y2. I need to find the slope of this particular line. So how I will going to find the slope of this particular line? Okay, I can extend this line like this. Okay, I can extend this line like this. Okay, and then I can say that this is a theta. Similarly, I can even draw a line which is what happened? Okay, a line. Okay, fine. Similarly, I can draw a line which is parallel to this x-axis from this particular line. Okay, so if this is theta, this will also be theta. I need to find the slope. So what I'll do, I will again going to draw a perpendicular line from this particular point. So this will be 90 degree, this will be 90 degree. If this is x2, okay, if this particular point is x2, this will be x2. If this is x1, this particular distance will be x1. So what will be this distance? This distance will be x2 minus x1. I mean change of x-axis is this between A and B. Similarly, over here, this distance will be y2 minus y1. Why? Because from here to here, this is your y2, and from here to here, this is y1. So this distance will be y2 minus y1. Okay, this is what is this distance. This is what is tan theta. Tan theta means whatever is there, the length of opposite sides, that is y2 minus y1, divided by adjacent side, that is x2 minus x1. So you will going to say that the slope of that particular line as y2 minus y1 upon x2 minus x1. Most important formula to find the slope of a line whose 2 points is given to you. So in other words, okay, so in other words, we can also say that y2 minus y1 as vertical rise. Okay, this is vertical rise. Okay, and this x2 minus x1 as horizontal distance. This is a horizontal distance, right? So this is how slope is derived. Slope formula is derived. Okay, fine. So next concept which we have is slope of a parallel lines. Okay, so if you have parallel lines, say I have parallel line, this is one line and this is another line. These two lines are parallel. So you know that if I'm drawing a x-axis like this, so this is the x-axis. So you know if this particular angle is theta, then this also will be theta. Why? Because these lines are parallel line. What is the reason? The reason is corresponding angle. From corresponding angles, I can say this angle is theta, then this angle will also be theta. Okay. So what is the slope of this line? Slope of this line will be tan theta. So obviously the slope of this line will also be tan theta. So whenever you have parallel lines, then the slope of parallel lines are always equal. Clear to you? Slope of parallel line is always equal. Okay, that's what is required here. Now next concept what we have is, what if the lines are not parallel, they are perpendicular. So that's what we will going to see here. say you have a line, one line is say this, and another line is say this. These two lines you have, okay, and this line is perpendicular to each other. Okay, this line and this line, they are perpendicular. So the slope of this line will be say m1, and slope of this line will be say m2. What will be the relationship between m1 and m2? That's what we have to find. So for that, let me consider that this particular angle is theta. So if this particular angle is theta, what will be the slope of this particular line, which is say OA? I'm giving the name OA, and this is say OB. So what is the slope of line OA? It will be tan theta. Okay, tan of this inclination. Similarly, if I say what is the angle of this, what is the slope of this particular M2? So I know this will be tan of this angle. Now, what is this angle? From exterior angle theorem, this particular angle will be 90. This particular angle will be 90, 90 plus theta. Correct? This particular angle will be 90 plus theta. Okay, and what will be this angle? This angle will be 90 minus theta. Okay, so I can write M2 as 90 plus theta and minus cot theta. This you have to remember. Okay, this you have to by heart. Okay, so my M1 into M2 will be what? My M1 is tan theta. So I will write tan theta. And what is M2? It is minus cot theta. So I will write cot theta is minus 1 upon tan theta. Why? Because cot theta is nothing but 1 by tan theta. So this tan theta and tan theta I can cancel, and I will get minus 1. So what I have proved? I have proved that slope of two perpendicular lines, the product of slope of two perpendicular lines, that is M1 into M2, will always give me what? Minus 1. That's what I have proved here. So here, what is difficult for you? The difficult for you over here is only this part, which we will going to study this not in 10th standard, but in 11th standard. So tan of 90 plus theta is minus cot theta. That you have to remember. Understood? Fine. So the next concept we have is condition for collinearity of 3 points. So if I have a line, if I have a straight line, and if I have 3 points on it, okay, then I can say these points as collinear points. Say the point is A, this is B, and this is C, and I need to check the collinearity of these 3 points. Then I have to take slope of AB, and I will going to take slope of BC. If they are equal, then I can say these 3 points are collinear points. They lies on a same line. Clear? Or you can even say that slope of AB is equal to slope of AC. This way also you can do. Either way, we can say that the points are collinear if the slopes are